Hey everyone, this is Dr. Walker. Let's look at a couple more examples from video 10 on kinematic equations. These examples will be a little bit harder or require some calculus. Let's look at the first example. And it's not necessarily harder, and this one doesn't require any calculus, but it's a problem where you have two objects moving rather than one object moving. So that's why I wanted to do an example of this type of problem. We have a cheetah that is waiting and hiding behind a bush. The cheetah spots a gazelle running past at 10 meters per second. The instant the gazelle passes the cheetah accelerates from rest at 4 meters per second squared to catch the gazelle. We're trying to find for the first part, how long does it take the cheetah to catch the gazelle? So it's really good to just picture what is happening. We have the cheetah over here, and then it's waiting, right? It's starting from rest, so the initial velocity is 0. And then we have the gazelle that is moving past and has a velocity of 10 meters per second. And as soon as the gazelle passes the cheetah, so when they're at the same position, the same horizontal position, then the cheetah is going to accelerate at 4 meters per second squared. So the cheetah is going to start moving a certain distance, and the gazelle is going to keep moving. The gazelle is moving at a constant speed because it doesn't say otherwise. And we want to know how long does it take the cheetah to catch the gazelle. So we know that when the cheetah catches the gazelle that they're going to be at the same position. How long does it take? So we have to figure out what is the time for them to be at the same position. So it just helps to draw a little picture. Definitely don't have to be an artist, but just to picture what is happening. So for part A, what we're trying to figure out is how long it's going to take both to be at the same position. So their displacement, the delta x, is going to be the same for both. So for the cheetah, the displacement is going to be given. You have to find a kinematic equation that has the correct variables. Can you find it? One that has displacement, initial velocity, acceleration, and also time, because we're going to want to solve for time. So if you look at your kinematic equations, hopefully you found this one, delta x equals v initial times time plus 1/2 at squared. And then for the gazelle, what equation do we use to find its displacement if it's moving at a constant velocity? So think about it for a second. When you're moving at a constant velocity, you can say that that velocity that you're traveling at is your average velocity, because that's the same thing. If it's constant, then that's also going to be your average velocity for the whole trip, because it's not changing. So we do have an equation that gives us the displacement once we have average velocity, because we know that average velocity is displacement over time, so displacement is velocity times time. We can call it delta t, but we can just call it t. We've already said that delta t is often equal to t, as long as we start from time is equal to 0. All right, so now all we have to do is set these two displacements equal to each other and then solve for time. So we're going to have v initial t plus 1/2 at squared, right? The delta x equals the delta x, equals the average velocity times time. Now, we said that the initial velocity was 0 for the cheetah, so that crosses out this whole term. And now, to solve for time, we can divide both sides by 1/2 at, and what we're going to get when we do that is we're going to cancel out everything except one t, and we're going to get t is equal to the average velocity over 1/2 times the acceleration. And now we can plug in our values. The average velocity was 10 meters per second divided by 1/2 times the acceleration, which is 4 meters per second squared. Nope, don't need to put the units. So 10 over 2, which is 5 seconds. That's how long it takes for both of them to move the same displacement. Now the second part is asking us, what is the displacement? So they both have the same displacement, so we can just solve for either one of them. For instance, for the gazelle, we have delta x equals v average times time, so we can just plug in the 10 meters per second for the average velocity times a time of 5 seconds, and that gives us 50 meters. If you plug in 5 seconds into the equation for the cheetah, you will also get 50 meters. So this was just an example where we do have two objects that are moving, and we have to combine their equations in order to solve for an unknown.